Hi again, this is our second video trying to solve a 3x3 system of equations with a parameter m. So far we did part A, where we had to use row operations to reduce the system to row echelon form, and the result is written over here. And now for part B, C, and D, we are going to be discussing for different values of m what's the situation with the solutions, if there are any or not, and if there are, we also want to find them. So for part B, we want to show that for one value of m, the system has no solutions. For the system to have no solutions, we need to get to an absurd situation where we have that something that is not zero is equal to something that is zero. If we look at the last row of our matrix, what we are saying is that the quadratic expression on m that we factorize minus brackets m minus 3 brackets times n minus 1 times z has to be equal to m minus 3 times m plus 1. So if we look at the linear expressions that we factorize, what we see is that when we have the value of m being equal to 1, what we're going to have is that 0z, so 0, is going to be equal to a number that is not 0, because if instead of m I write 1, then I'm going to have negative 2 times 2, so negative 4. So we get to the absurd situation where we're saying that 0 is equal to negative 4, and this is not true. And then this is when we have no solutions for the value of m equals 1, and this will be the answer for part B. No solutions in this case. For a different value of m, the problem says that there are infinitely many solutions, and that's going to be for the value of m equals to 3, because if you see, we have the expression m minus 3 on both sides of the equality. So if m is equal to 3, we get in the situation where we have that 0 is equal to 0. So we get on our row echelon form a row of zeros for the third row. So what will be our row echelon form in this case? We don't need to write a row of zeros. We are going to have the 4, 4, 1, 1. And then for the second row, we have 0, negative 12. Now m is equal to 3, so we're going to have minus 12 plus 1, so minus 11. And then we are going to have 13 on the other side, because it's 4 times 3 plus 1. And then, well, we can write a row of zeros on the bottom. This is the system when m is equal to 3. And then this system has infinitely many solutions. Of course, we want to find them. And we are going to do so with our calculator. So we are going to write the system on the calculator, and we're going to find the solutions. And the solutions are going to depend on a parameter, because now we have 2 equations and 3 unknowns. So let's try that. I'll write the system in the calculator. So I'm going to go to Menu and Algebra and Solve System of Equations, and I want to solve a system of linear equations. The number of equations that I have are 2, but I have 3 variables, so x, y, z. So I need to write the equations over there. I'm getting this from the augmented matrix. 4x plus, sorry, keyboard is not in the right language. So 4x plus 4y plus z is equal to 1 is the first one of the equations, and the second one is negative 12y negative 11z is equal to 13. And that's the system I want the calculator to solve for me. And here is the solution. So the calculator wrote the solution where the third value, so the z value, is anything, called in this case C1. And then we have, dependent on that value of C1, what has to be the value of the first entry, the x, and the value of the second entry, the y. So let's write that down on our solutions with notation a little bit more familiar to us. Let me just copy this one so we have it in front of us. in 1 second. So I'll write here solutions. I will write this is gonna be for the first entry. I need 2 times, I'll call the parameter here just Z, why not? Z plus 2 over 3. The next entry minus 11Z plus 13 over 12. And then Z is the last entry, and Z is a real number. For the last part of the problem, we want to see that there is a unique solution for all other values of m. So if m is different from 1 and m is different from 3, I want to see that there is a unique solution, and that solution is going to be in terms of m. And yeah, we need to find it. I just want to mention something I should have mentioned earlier, is that m is a parameter, and we say that m is not 0, and that was important at some point when I had to multiply a row by m. I didn't mention anything, but actually that was a legal move for us to do. So let's go ahead and find the solution in the case that we have a unique one in terms of m. This is part D, and we know that m is not 3, and we know that m is not 1. So for the last row, I'm going to divide both sides by m minus 3 and m minus 1. So I'm going to get that negative z is equal to, and then the expression m minus 3 is going to cancel, and I'm going to have m plus 1 over m minus 1. So the value of z is going to be, I just need to change the sign. Let's write m plus 1 over 1 minus m. So for our parameter m, any value different from 3 and 1, this is the unique value of z. We need to use that unique value of z and the second row of our row reduce form to find the value of y. We have, according to our row echelon form, that negative 12y plus, and then we have minus 4m plus 1 times z. We have here z m plus 1 over 1 minus m. All of this has to be equal to 4m plus 1. I need to isolate y here to find what the value of y is. Not looking pretty, but we can do it. I'll keep this expression over here. So 1 minus 4m times m plus 1 over 1 minus m. And then I'll write minus this expression, so minus 4m plus 1. All of this I'm going to multiply it by 1 over 12, and this is equal to y. We need a little bit more space to try to write y a little bit nicer, because we need to substitute it in the first row to find the value of x, and that doesn't look very nice. So I'll try to do common denominator 1 minus m on the expression that defines y. So if I have 1 minus m, I have from the first term 1 minus, so that's 1 minus 4m multiplied by m plus 1, and then minus 4m plus 1 multiplied by the 1 minus m from the common denominator. Let's see if we can write this a little bit nicer. 1 over 12 still, and I'm just gonna expand and then see if we have some common denominator or something we can work with. So I'm gonna have minus 4m squared, and also there is minus 4m, and there is also plus m and plus 1, and then I have minus, I'll keep parentheses for a little bit. I'm gonna have minus 4m squared, and I'm also going to have plus 4m and minus m and plus 1. That's my numerator. and 1 minus m is my denominator. And this is, let's see, I'm going to have the lack of cancelling the terms with m squared. That's nice. And then this is minus 3m, and here we have 3m, and there's a negative sign outside, so minus 6m, and then I have 1 and then minus 1, so they cancel. It's kind of nice. So over 1 minus m, I can cancel the 6 to have, and I also can change the sign, so I will write m over 2 times m minus 1. Oof, yeah, that's way nicer. To move on to, I'll write here what the first row says, so we can substitute for x. So 4x plus 4y plus z has to be equal to 1. I have the value of y and z, so I want to find the value of x with a little bit more of space. And just write that this is actually the value of y that I want to work with, and not the unsimplified one that I found before. This is nicer. Okay, so 4x is equal to 1, and then I have to write minus z. So I'll write plus m plus 1 over m minus 1. I change the sign instead of writing minus z. And then minus 4y. So minus 4 times m over 2 times m minus 1. I can simplify a factor of 2 over here, and then I have 4x is equal, and I'm going to take m minus 1 as common denominator. I need to then multiply the term 1 by m minus 1. So I have m minus 1, and then plus m plus 1, and then minus 2m. And then I have here m plus m minus 2m, they cancel, and minus 1 plus 1, they cancel, so this is equal to 0. So actually x is equal to 0. So the solution we need to write to finish the problem, this is when when m is not 3 and m is not 1, we found a unique solution which is 0 for the first entry, m over 2 times m minus 1 for the second one, and m plus 1 over 1 minus m for the last one. And here m is a real parameter, and m is not 0, it's not 1, and it's not 3 either. And that was the final answer for the last part of the problem.